Hello Internet, and welcome to a new episode on my DIY channel. I make this video in the evening hours because during the day it's pretty darn warm here in Germany. In the past days we had around about 40 degrees Celsius. It's real summertime in Germany. But instead of sitting in the basement for cooling, I provide a very nice topic for you. So today's episode is all about combining wooden elements and 3D printed parts. I'd like to invite you to go with me through the individual steps of the creation process. Let's have a look. As a design study, I chose a projector stand. The aim was to find a design that combines wooden elements and 3D printed components working together smoothly. In addition to functionality, I wanted to use an interesting shape. For the design of the workpiece I used Fusion 360 and for slicing the software Cura 4.0. I roughly sketched the design with a pencil and oriented myself to the dimensions of a typical projector. The design should not require too much space on an office desk. The stand for the projector should be pivotable and also lightweight as possible. For the wooden elements I used 18mm plywood, combined with 3D printed parts made of PLA and PETG. The print with PETG requires a nozzle temperature of about 220 degrees Celsius and a bed temperature of around about 80 degrees Celsius. But keep in mind, the settings can vary between filament producers. To print PETG, I used the Anycubic i3 Mega, which is better suited for higher temperature and its smaller print bed. In order to find the correct temperature for my printer and the PETG filament that I used, I previously printed a heat tower. As a result, the optimum temperature was between 220 and 225 degrees Celsius. The PETG components printed in blue. For printing with PLA, I used black colored filament. The PLA is printed on my Creality CR10S4. This printer gives me very good results with PLA and can print big objects on his 40 by 40 centimeter sized bed. I selected a print temperature of around about 220 degrees Celsius and the print bed temperature of 60 degrees. I will show the detailed settings in the video, so you can pause the video and have a look on my settings. On the Creality printer, I use a combination of glass plate in combination with hairspray to make the print stick to the print bed. In order to save some time for printing, I used a layer height of 0.3 millimeters. The print quality is slightly worse. In particular, the print of overhangs is affected. Since this is a design study, I have accepted the poorer quality to print faster. Of course, a setting of 0.2 millimeters or better 0.1 millimeter for the layer height would result in much better quality of the surface, and in particular for the overhangs. In Cura, I only activated support for jobs with more than 85% overhang, so there are many areas with overhangs. They are printed without support. This is especially important for the cone-shaped cavitation on the side parts. Here I did not want any support. Here you can see on the sides facing the print bed the slight or missing overlap of the layers. So there are several possibilities you can solve this. A. You can decrease the layer thickness to have less overhangs between the layers and no print lines in the air. Or B. Adjust the design and make the recess one-sided so there are no overhanging parts. And C. If I mirrored the finished model, I could take the less beautiful sides inside of the model, and so they are not visible from the outside. Of course, an additional surface treatment by grinding and the use of a filler and primer can create a very smooth and nice looking surface. Here I screw the parts together using a threaded rod and a screw on the inner side and a self-locking screw on the outside. Even with a coarse setting of 0.3 mm layer height, I got nice looking results printing PETG on the Anycubic i3 Mega. One reason is that I used a printing temperature on the upper range. In this case, round about 225 degrees Celsius. In the future, I would like to use Fusion 360 to carry out an FEM analysis to find a solid shape and save unnecessary material at the same time. And now the final assembly. Also, I make sure everything fits and is good looking. because I printed in the upper heat range. It came to a little bit of stringing. To get rid of it, I used a small gas lighter and burned the strings carefully until they are nearly gone. I designed this small workpiece in advance to some bigger and more complex workpieces coming up in the future. I hope the video gave you good insight into my approach, and I would be happy about an exchange of information and suggestions. Please enter the questions and your ideas in the comment section below. I will answer them if possible. I'm currently working on some nice and interesting topics for the future, so if you're interested in those topics, press the subscribe button and you don't miss any new content. That's it for today. It was great fun designing and grading the case study. You will find some photo shots of the final projector stand at the end of the video. I hope you enjoyed the video and I'm happy about the thumbs up. The design of the workpiece with fusion as well as the printing were very interesting for me. And I would like to do more videos in this subject area. I also like the connection with 3D printing and other DIY techniques. The stand is intended for use with a small office projector. To do a stress test, I took an old slide projector, which is about 4 times as heavy. Because it's good old analog technology. It was no wonder that the lever could not hold the weight. So I strengthened the lever slightly . In order to print the layers cross to the shear forces, I have printed the lever lying down on the print bed. With the disadvantage that I now have to remove the support material and the surface quality of the supported parts will be less good. I would be glad if you continue to share your ideas and suggestions with me that's all for today. So all the best from my side and see you soon.